So I'm a trained geneticist, so I'm very interested in trying to understand within a particular population why some people get disease, and gout is a disease I focus on, and why some people don't. That understanding, whether it's understanding the role of inherited genes or environmental exposures, will lead us to different ways of intervening, whether it's medical or through the environment. And those sort of interventions that you outline in the churches are exactly the sort of interventions that hopefully the research leads to as well, in informing that. So gout is caused by high levels of uric acid, and I'm sure this audience is pretty well aware of the high prevalence of gout in Maori and Pacific populations. And it does have a reasonably strong genetic basis, and it's all about the ability to excrete uric acid. So on the right there, renal excretion of uric acid with the genetics behind that. On the left, diet is important, and today I'm going to talk about fructose and sugar. That's overproduction in the body. It's very treatable, okay, and it's a big message. You know, we talk about diet raising uric acid levels, but really somebody who's on a urate lowering drug like allopurinol, and they get their urates down, it's a very effective drug, then diet becomes less of an issue. They can eat foods that they enjoy. So that's a very important message about, really should be medicalised gout. It's very treatable. So you get this condition called hyperuricemia, elevated uric acid levels, and then in some people you get crystals precipitating in the joints. That's on the far left there. And then in some people, again, you get the immune reaction, the really severe pain and inflammation causing the gout attack. And again, there's genetics involved in all of these processes, and that's an area we're looking at. Gout in New Zealand is very prevalent, and those on the right of that graph at the top are Maori and Pacific men. It becomes more prevalent as you get older. And if you get to the age of 70, for example, if you're a Maori or Pacific man, you have a roughly 1 in 3 chance of having gout, very prevalent. It starts in earlier age in Maori and Pacific and is higher in men than women. And we know that genetics plays a role, and we also know when we look in ancient pre-colonised New Zealand and ancient Pacific that there was still gout. So that tells us that genetics, genetic susceptibility, so to speak, is important if it was occurring before westernised lifestyle. But uric acid is a very interesting molecule. It's actually a good thing to have high levels of uric acid. So the genes that are leading to uric acid, and this is a message for communities as well, they're good genes because uric acid is an antioxidant, and it's also more and more evidence possibly related to being an antioxidant that it's neuroprotective. So if you have gout, you're less likely to have neurodegenerative diseases like Alzheimer's and Parkinson's. So having high levels of uric acid, there's good reasons for it, so they're good genes to have, and gout is an unfortunate consequence. So focusing on fructose, so sugar, sucrose is 1 part fructose, 1 part glucose. And they're metabolised very differently, and we know a lot about the metabolising of sugar in the liver, particularly fructose. Glucose is a good guy. Its metabolism is regulated. The body knows about the levels of glucose, and when we have too much, we can store some of it in the liver. But fructose is completely unregulated, and particularly the fructose that's delivered in a sugary drink. It's already dissolved. And one of the things that I facetiously say at times to people, if you want to give your kid a can of Coke, it's probably, there's no evidence behind this, but it's a bit facetious, give them 10 teaspoons of sugar instead. It's probably cheaper, and it'll take a bit longer to dissolve and get into their system. But once it's in, a soft drink is ingested, it goes to the liver, and the metabolism leads to all of these things. This is what drives the association of sugary drinks with gout. It leads to uric acid, it leads to bad lipids, which can cause heart disease, leads to insulin resistance, which is a diabetes, fatty liver, inflammation, high blood pressure. And there's many epidemiological studies, and I'm going to show you just one on gout, but associating increased sugary drink consumption with all of these metabolic conditions. So in our study, we aim to test for association between sugar sweetened drink and fruit juice consumption and gout in New Zealand. And we used survey data from 1,205 people with and 719 people without gout, which was part of the data we collected in our genetics of gout and Aotearoa study. So these are the questions up there that we asked. We also, because fructose is the sugar under examination here, and fructose is a fruit sugar, we also asked about fruit consumption in the same study. And most of the majority of people who were recruited in the study were recruited from South Auckland, recruited from workplaces. We were trying to target men, so we went into workplaces. We found that roughly 1 in 6 Pacific people, 1 in 7 Maori and 1 in 20 Europeans in the study reported drinking of more than 4 servings of sugary drinks a day, so that's roughly a litre a day. And when you go into the workplaces in South Auckland, hot places, and you'd have at least this was several years ago now, and I think the workplaces are addressing this issue, but you would have men going on their break and knocking back a 500-600 ml bottle of Coke simply because they're very thirsty. So what we found was that the more sugary drinks you drink a day, and particularly as you get up to 2 or 3 and 4 or more sugary drinks a day, the risk of gout increases. So the blue is Europeans, and in fact, Europeans, if you're drinking 4 or more sugary drinks a day, your risk of gout is 400% more, 4-fold more, but certainly Maori and Pacific as well, the blue and the green and red lines increase. And what we also found, and it's not presented, I'm not presenting the data here, is that this increased risk of gout, which is driven through an increase in uric acid levels, is restricted to people who are already overweight, and that's an interesting finding as well. Already overweight or obese, that's where this effect is occurring. We found no relationship between fruit consumption and gout, so that's at least in our study in this population is a relief that we wouldn't want to be changing any of those 5+ a day messages. One of the other things that we have looked at in terms of gout is there are a number of dietary triggers, and we really don't know why these various foods trigger gout, but anybody who is working in the gout field and people with gout will know that seafood and fish, kaimoana, mussels, kina, things like that are potent triggers of gout. And what we did in this study here was, in the same genetic study, we also asked people an open-ended question, what triggers your gout attacks? And roughly 2/3 of people have triggers, 1/3 don't, and what we've listed here are from left to right are the most common triggers. And we can see sugary drinks there as the 7th most common trigger. And one of the very interesting reasons why we did this study is actually part of a separate qualitative study interviewing men with gout to get an understanding about their understandings. And one of the things that came out was tomatoes. And tomatoes are not an accepted food in the literature about a trigger of gout, but yet they come out as the 4th most common self-reported trigger of gout, and we're following up on that finding as well. And I think that's just emphasises to me as a biomedical researcher, and emphasises what the Reverend said, is that communities have a lot of knowledge and really need to be heard in these sort of in these settings, and it's really great to see communities represented here today. Finally, this is the final slide here. So we also, with Professor Nicola Dalbeth from the University of Auckland, have done this clinical study where it was led by Nicola, and it involved giving people an acute amount of fructose, 60 grams, so that's quite a lot of fructose, and evaluating their uric acid responses. And in this study we were interested in the differing responses of people according to their genetic makeup, but I'm not going to talk about that today. But one of the key findings from this is when so what we did is we took, from memory, 75 people, I think 25 were European, 75 people, roughly half were European and half were Maori and Pacific, healthy, relatively young people in their 20s and 30s. Gave them this bolus of uric acid, and we can see on the left there that we can see how Maori and Pacific people have inherently higher uric acid levels, and that's a well-established fact than Europeans. But one of the most important things here is that on the right you can sort of see the raise in uric acid levels as a result of ingesting the fructose, which is completely consistent with the biochemistry I showed you before. But we can see that there's a greater rise in uric acid levels with ingestion of fructose in Maori and Pacific people on the left, so it's the top line, compared to Europeans, which is a bottom line, and the graph on the right, a greater increase in uric acid. So this is, I think, a combination. What we're seeing here is that Maori and Pacific have higher urate levels and respond, at least in urate, and we're also starting to look at lipids and things like that, respond differently and possibly, one could say, worse to fructose than Europeans. And I think that just emphasises, provides more evidence that sugary drinks, at least in the context of gout and uric acid, are not a good thing, and certainly in clinical care now in New Zealand, and the messages we're getting through via the Arthritis Foundation, Arthritis New Zealand, and the Maori Gout Action Group I'm involved in Counties Manukau, is becoming, we think, pretty common knowledge that sugary drinks are another food to avoid completely if you have gout. So I'll leave it there. Thank you very much.